an asynchronous day and a Mr. Kulik was absent day. So you guys are probably really ready for some questions.
I'm very lost on everything.
Okay, well, follow me. I'll show you the path. Rita. Yeah, that's fine. 10 from the problems. This guy right here. Okay? So this is a simplifying problem. My general advice on a simplifying problem is to first look for algebraic things that you could do, and then to look for identity things to do. Okay? So if we're looking at number 10, do you see anything algebraic to do?
No. There probably is something, but I don't see it.
Totally joking.
Oh, because
Jacob.
You can take out or factor out.
That's what I would think right away, is that you can factor out a tangent from each of these. That would be what I would do. Also acceptable algebraically to do would be to make a common denominator, although that turns out to be maybe the long way of going about doing this. So if I factor off a tangent, I get to this, right? Everybody okay with that? Okay. Now, we've done something algebraic. Again, you could make a common denominator here. I would not. Instead, I would look to use an identity. What could I do here? Yeah, so Nolan's saying that 1 over cosecant squared is sine squared. And 1 over secant squared is cosine squared. And that is just 1. So this thing just turns into tangent x. That would have been the easiest way to get there. Now, if you started making common denominators, you can get to the same spot. It's going to get a little messier because you're going to end up with like kind of a lot of fractions rolling around for a long time.
I tried doing that. It didn't work out.
Yeah, it's not incorrect to do it that way. It's just going to be a little bit messier. So it's going to be a little bit more difficult to kind of keep track of everything.
Yeah.
What we did here was the easiest way, I think, to kind of attack this one. In general, if you start trying to do something and you're like, I don't like where this is going, there's nothing wrong with just like quitting, erasing, and trying something else, right? Like for these kind of simplification problems, there's not one way to do it. So if you're like kind of get to the point where like I'm lost in the weeds, I feel like I've either made a mistake or just like have made some bad choices, just scrap it and try it over. Do something else, you know, or go back to a spot where you're like, I felt pretty good and I made this decision here. Maybe I'll try something else. There's nothing wrong with doing that. Is that okay?
Yep, thank you.
Sure. Sophia. Same thing?
Yes.
Sure. Okay. So again, algebra identity. What do you want to do first? Okay, sure. So Sophia says I can turn that into cotangent. And what else do you notice that you could do here? Yeah, just do a little bit of reducing. Is everybody cool so far? Now we can probably do a little bit better than this. But to do that, I'm going to have to be using the reciprocal and quotient identities probably to do that. if I'm going to do that, the easier way to think about this is going to be, since I'm going to make some fractions here in a second, is to maybe think about it this way. So when I think about cotangent, that is cosine over sine. And 1 over cosecant is going to be sine over 1. And then I just end up with cosine. So this kind of trick right here, where I take something that's written as a fraction, think about it as the product of two things, is often a nice little trick to kind of keep things from getting too messy. In my experience, we often have difficulty when we have like fractions stacked on top of fractions. Like, what the heck do I do with this? You can avoid that like intellectual pitfall if you just kind of separate it as the product of two things. Giselle. Sure. So we're doing, everybody's okay so far? This is going okay? You're going to stop me if you don't like what I'm doing, or if there's like, hey, why didn't you do this or that or another thing? You can always stop and ask those questions, right? And it's really smart to do that as well, right? Like, those are all good things to do. Oh my God. Like, just like hold still for me. Okay. So here's 13. Great. What was any first thoughts?
I changed cos, like the cos pi over 2 minus a to sine a.
Yeah, that's great. So again, usually a first step on any of these like simplifying ones is to get all the variables the same. Okay. Great. I like that. Then what? Okay. So at the same time, let's group these two guys together, right? What's sine alpha plus sine alpha? 2 sine alphas, right? And then Nolan says I'm going to think about tangent as sine over cosine. So those will cancel out. So what's 2 sine alpha minus 1 sine alpha? Just 1 sine alpha. Does that feel okay?
Yeah, it does. It's just like it's confusing to know which one to use, like at the right time, like when to stop and stop.
So in general, for these simplifying ones, you're probably going to stop when you get down to a single identity. Now, in terms of what to pick, well, primarily you're going to be using the reciprocal quotient in Pythagoreans. You probably aren't going to pick something other than that unless it's like super obvious, like we had right here, where it's like, okay, well, clearly I need to use a cofunction to do that. But other than that, those are going to be your primary 3 tools.
And then for 14 is the best option to do like the common denominator.
Yeah, that's absolutely what I would do first. What would we have to multiply to each of these to make a common denominator? Great. So I'm going to end up with 1 plus sine y plus 1 minus sine y all over 1 plus sine y times 1 minus sine y. Agreed? Okay. Well, look in the numerator. What can I do up there? And those guys, I have a plus sine y and a minus sine y. So I'm just going to end up with 2 in the numerator. Now, is there anything I can do with that denominator? Yeah, it's a difference of 2 squares, so let's FOIL that out. What's 1 the same as? What does 1 equal? Isn't that the same thing as sine squared plus cosine squared? And 2 over cosine squared then is? Well, what if I write it this way? 2 times 1 over cosine squared. Isn't that just 2 secant squared? That's as good as you'll do. Down to 1 trig term. Jake? Sure. Does that feel okay, Giselle?
Yeah.
So again, like, why did I keep going here? It's, well, felt like I could probably get that down to like a single thing instead of a fraction. So we just tried. Sometimes you'll be able to do some more. Maybe sometimes you wouldn't, but probably most of the time you will. What else do you guys want to look at? Sophia. 54. Sure. Okay. Do you have a preference on which side you wanted to start with? You want to start with the right side?
Okay, that's how one I say.
No, it's okay. I think the left would be the more natural one.
How do you know like where to start?
So here's what I would say. If I look at the 2 sides, to get from the right side to the left side, I'm going to have to factor. Right? Because that's the only way you're going to get like 2 parentheses multiplied to each other, is you'd have to do factoring. To go from the left side to the right side, what are you going to have to do? Foiling. Which is easier? Which would you rather do, FOIL or factor? FOIL is way easier than factoring. Right? That's why I would choose the left-hand side here, because I would rather FOIL than factor. Because foiling is just like, I don't have to think, I don't have to like figure out the things that multiplied and give me added and do any of that. Just like all you do is just multiply stuff. Factoring's way trickier. I'd much rather FOIL than factor. That's how that's what I'm looking at to know which one I would rather do. Is that?
Yeah.
Okay. You can see what I'm saying?
Yeah.
Okay. All right. So, what do I get when I FOIL this out? Right, because this is x sine A plus x cosine A times x sine A plus x cosine A, right? That's what this means?
Yeah.
What do I get when I FOIL that out? Oops, 2x squared. If you don't see it, write it out and do the FOIL yourself, but I promise you that's what you get. All I did was FOIL there. This is the maximum amount of zoomage I get, apparently. From here on, I just have to write bigger, apparently. Nolan?
So when you FOIL stuff, you have to square the axes too.
Well, if you're doing, what you'd have is like x sine x, or x sine a times x sine a. So x times x is x squared, sine a times sine a is sine squared. So you get x squared sine squared. Does that make sense?
Yeah.
All right, let's look at where we're trying to get to and compare what we have right now. Oh my God. This is why it just hates me when I zoom in like this. Those two parts are the same, right? Everybody see that? So I'm not going to touch that part in green. Somehow then, this stuff has to turn into just that. Well, if I look at those two things I highlighted in blue, do you notice that there's anything algebraic to do? Yeah, if I factor out an x squared, I have sine squared alpha plus cosine squared alpha, which is 1. And that's exactly what I needed to have happen, right? And I'm done. I'm not going to write it with just the x squared there times 1. You know what I mean? Do you guys see what happened? So see the stuff in blue? I factored the x squared off. And that was pretty easy. To go backwards would have been pretty tricky. To go the other side, Sophia. What would have been, what's the tricky step that you would have had to make? You would have had to see x squared as x squared times 1, and then replace the 1 with sine squared plus cosine squared in order to get the stuff there that you needed to factor. Yeah. Woof. Would have been tough to get there. Would have been tough to get there. Or harder to get there anyways, right? But going this direction was relatively straightforward. Giselle.
Maybe number 17.
Sure. Is that the solving section?
Yeah.
Sure.
You get to do every single one of those, like all 4 A, B, C, D, all.
I mean, yeah.
That's a lot, Mr. Floyd.
Here's the deal though. After you do part B, the rest of them are all just like really pretty easy. So that's what I'm going to start with. I'm going to do part B first. So to do this, what am I going to do? I'm going to go to the unit circle and look for the place where tangent is equal to 1. What is tangent on the unit circle? Y over x. So y over x equal to 1 is the same thing as when x and y are the same, right? So that happens in 2 places. It happens at pi over 4, and it happens at 5 pi over 4.
I get A and B.
Okay. So A is between 0 and 2 pi. So if I set k to be 0, I get pi over 4. If I set k to be 1, I'm going to have something that's too big and not in between 0 and 2 pi. So I'm not going to even bother with it, right? If I take pi over 4 and I add 2 pi to it, it's certainly going to be bigger than 2 pi. Everybody agree? Okay, if I try to make k negative 1 and I subtract 2 pi, well, pi over 4 minus 2 pi is certainly smaller than 0. So that's too small. I'm not going to bother with that. So I found all the solutions from pi over 4 plus 2 pi k that are between 0 and 2 pi. Giselle, does that make sense?
Yeah.
Okay, so I'm going to move to 5 pi over 4 plus 2 pi k. If I set k to 0, I get 5 pi over 4. That's between 0 and 2 pi. If I set k to be 1, well, that's going to be too big. 5 pi over 4 plus 2 pi is definitely bigger than 2 pi. If I set k to be negative 1, 5 pi over 4 minus 2 pi is definitely smaller than 0. That's too small. So those are my only answers for part A. For part C, yeah.
In the answers,
Okay.
for part B, they only have 4 or pi over 4 plus pi, and like they don't have 5 pi over 4.
I'll explain in a moment. I can show you why. It means the same thing. You want to know why?
Yeah.
Look at pi over 4 and 5 pi over 4. How far apart are those? 1 pi, right? So if I take pi over 4 and I add 1 pi to it, I get 5 pi over 4. If I add 1 pi again, that's the same thing as anything I would get from here, right? If I add 1 pi again, I would get the stuff in there. So it's the same, having each of these two separately plus 2 pi k is the same thing as having one of them plus 1 pi k.
So it's fine if you put both of them.
Sure, it's the same thing.
Okay.
Yeah, it means the same thing. I'm just, when I write my answer keys, I'm usually going to select to do it the most compact way because it's like less stuff to type.
Yeah.
But this is equivalent. If you generate like the infinite answers with, why is that erasing? It's so irritating to me. If you generate your infinite answers, you're going to get the same set either way. So they are equivalent. Okay. So C is all the answers between negative 2 pi and positive 2 pi. Well, my two answers for A are certainly in between negative 2 pi and positive 2 pi, right? So I'm going to just copy those in. Then I'm going to go back to my answer for part B. If I set k to be 1, pi over 4 plus 2 pi is bigger than 2 pi. So there's no answers bigger than pi over 4 coming from that first solution. If I set k to be negative 1, pi over 4 minus 2 pi is negative 7 pi over 4, which is small, or which is still bigger than negative 2 pi, so that's a solution. If I make k negative 2, pi over 4 minus 4 pi is definitely too small. That's much smaller than 2 pi. So I found all the solutions between negative 2 pi and positive 2 pi from pi over 4 plus 2 pi k. So now I'll move over to 5 pi over 4 plus 2 pi k.
What about the negative 3 pi over 4?
I'm going to get it in just a second. If I look at 5 pi over 4 plus 2 pi k, if I make k equal 1, so I'm doing 5 pi over 4 plus 2 pi, that's too big, right? That's much bigger than 2 pi, so that can't be a solution. If I make k negative 1, 5 pi over 4 minus 2 pi k is negative 3 pi over 4. That is in between 2 pi and negative 2 pi. If I make k equal negative 2, 5 pi over 4 minus 2 pi plus, or I'm sorry, minus 4 pi. I'm sorry. If I take 5 pi over 4 minus 4 pi, that's definitely smaller than 2 pi, so that's too small. So those are all my solutions. For part D, we're looking at things in between negative pi and 4 pi. So I'm going to just take a look at my solutions here. I'm going to grab everything that's bigger than negative pi. Not negative 7 pi over 4. That's too small, right? That's negative 175, 1.75. You see? So I want to reuse as much of my work as I can. But those three are still in the interval I'm looking for. And now I'm just going to go back to my infinite solutions. I'll look at the first one. I've already know that I found everything small. So I just need to look at what happens when k gets bigger. So when k equals 1, I get pi over 4 plus 2 pi, which is 9 pi over 4. If I add, or if k is 2, I have pi over 4 plus 4 pi. Well, that's certainly going to be bigger than 4 pi, which was the top of my interval. So that's it for that solution. So I'll go to the other infinite solution. So if k equals 1 there, I have 5 pi over 4 plus 2 pi, so that's 13 pi over 4, which is 3 1/4 pi. And if another 2 pi to that, that's too big, right? That's 5 1/4. So now I know I'm done. I've handled everything. Do you see what I'm doing or no? Is it not clicking? You don't look happy.
No, I know.
Okay. So like if I take this and I just generate answers for that, it's like pi over 4. And if I'm adding, I'd get like add 2 pi, that's 9 pi over 4. I add it again. That's like 17 pi over 4. If I add it again, that's like 23 pi over 4. Not 20, 25 pi over 4. Or if I subtract it, I get like negative 7 pi over 4. And I subtract again, I get like negative 15 pi over 4. Whatever, I can do this as much as I want, right? And then I'm just looking at those and seeing which ones are like in the interval that I'm looking for. So I'm just taking that infinite answer and generating solutions until they land outside of the intervals in parts A, B, and or parts A, C, and D, and writing those down. And I do the same thing with the other one, right? Like I get 5 pi over 4. If I add 2 pi to it, I get like 13 pi over 4. And then 21 pi over 4. Yada, yada, yada. 29 pi over 4, whatever. And then I'm subtracting, I get negative 3 pi over 4. Negative 11 pi over 4, etc. And then I'm just, again, I'm looking at those answers and just pulling the stuff that fits in the interval. That's all I'm doing. Once I have that infinite answer, I can find all the solutions for any interval. It just have to enumerate them until they stop fitting. You know what I mean? So if I'm looking for the stuff between, like negative 2 pi and positive 2 pi, it's okay, well, that one, and that's it. Right? Everything else is either too big or too small. And I go down here, it's like, okay, it's that one, but everything else is either too big or too small. That's really all I'm doing. I'm just taking that infinite solution, iterating answers until they land outside of my interval that I'm trying to solve over. So once I have my answer for part B, it doesn't matter the interval that I give you. It just keep adding 2 pi or subtracting 2 pi until I get an answer that doesn't work, and then I stop. and move on to the next one. Is that? Yeah, you don't seem happy, but I'll just let it go. Sophia.
For 23, when it's like cosine,
Uh-huh.
whenever I know the x and make sure it has to be square root of 3 over 2.
Uh-huh.
And on the answer key, like it's pi over 3, not pi over 6.
So you think there's just a mistake on the answer key? That's possible.
I don't know if I'm
Probably not for one like that. Let's just pull up a unit circle real quick. Where did that go? There it is. So it should be pi over 6, and you say it's not?
No, it says pi over 3.
Okay, so that's a mistake then. Yep. That's what that's going on. So probably the easiest thing for Mr. Kulik to do would be just change the problem to be sine then, right? And it should be correct. Maybe less things to change than on the answer key. Oh, my apologies. Good question.
I have one more question about this. You do 62.
62, sure. Oh, I see. It looks scary to you, huh? Okay. Well, which side do you want to work on? You pick left. Okay.
Wait, in the rule, it said pick a more complicated side. So
The advice is to typically do that, yes. That's true. I would not want to do it in this case. And let me explain to you what I'm seeing when I look at this and why I'm saying that. This is what I see. Sine squared is the same thing as like 1 minus cosine squared. So at some point, we had to do some kind of factoring where this guy got reduced out of there, which means I'm going to have to factor this quadratic whose leading coefficient isn't 1. That stinkos. Having to factor a quadratic whose leading coefficient isn't 1, that's like a pain in the butt. If I work the other side instead, because I see this, I know I just need to multiply the top and bottom by 1 plus cosine, and then everything else should work out in my favor. That's what I would prefer to do. But like, that's kind of an advanced thing for me to see. Like, now that I pointed out to you, you're like, okay, sure, I understand why you're going to do it that way. Now, is it okay to do what you're asking to do? For sure. For sure you can start on the left side. Absolutely. It's just going to be like, you're going to have to go through that factoring hurdle, which is not the end of the world, but like, if I can avoid having to do that, I mean, like, I would avoid having to do that by just looking at it a little bit more closely and going, what am I going to have to do to get there? Now, have you done enough problems to be able to do that naturally? In like the 10 seconds that Mr. Gulick looked at that and was like, yeah, I'm not sure I'd want to do it that way. No. And is that okay? Yes. 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 It'll still work. You can do it that way, the way that you're describing wanting that your intuition is telling you to do it. Yes. Now, I'm going to tell you a secret. For the most part, like, these are ones, if you've done 3 or more, like maybe 3 or 4 steps and you're still like nowhere in sight to an answer, there's probably an easier way. Because Mr. Kulik's not a madman and is going to give you something that takes like 15 steps to sort to the answer. Most all of them are going to have like some kind of sneaky way that you could have done it pretty quickly. Like if you make the observation I made right here, if you multiply the top and bottom by 1 plus cosine on the right, the thing just kind of tumbles right out at you and you're almost done after one step. But as you saw, you had to like kind of go against the general advice to do that. You know what I mean? So let's do it your way, okay? And then I'll show you what it looks like doing it my way. Does that feel okay? Of course. And this, I hope this is helpful, right? To talk through like, what happens if I did it this way? What would you do? Blah, 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 blah. Yeah, right? Like, this is how we're going to build up our intuition. Okay. So we're going to work on the left-hand side. First thing I'd hope that you would notice is you'd look at where you're trying to get to. So this would be hopefully the key that I would see is that, okay, sine squared is the same as 1 minus cosine squared. And then I'm going to have to factor that and do some reducing somewhere, which means I'm also going to have to factor this numerator, right? So let's start by doing the factoring part. Need to multiply to get the leading or the constant times the leading coefficient, and then add to give me that null term. What multiplies to give me -4 and adds to give me -3? -4 and +1. So what I'm going to do is I'm going to take this and we're going to break up that -3 cosine and turn it into -4 cosine plus 1 cosine. And then make two groups. From the first group, the greatest common factor I can take out is a 1. From the second group, the greatest common factor I can take out is a cosine x. If I then look at these as my two terms and look for a greatest common factor, I have a 1 minus 4 cosine x in common. And then left over, I have a 1 plus cosine x. So that's the numerator factor. Now I'll write that as 1 over cosine squared. And 1 over cosine squared, I recognize that factors. And I can reduce those, and that's what I'm looking for. You see that? Had we decided to work the right-hand side, which would have been, again, Mr. Kulik's expert level, like I've done thousands of these problems, intuition, I would have just started by multiplying the top and bottom by 1 plus cosine x. So when I FOIL this top part out, I get 1 plus, or I should say minus 4 cosine x plus 1 cosine x minus 4 cosine squared x over 1 minus cosine squared x. And when I group my like terms in the numerator, and turn 1 minus cosine squared into sine squared, I'm done. And that's why Mr. Kulik was like, I think I'd rather work on that side, because avoiding that factoring where the leading coefficient isn't 1 just saves me a lot of hassle. Not that it's that hard, but it's like, it's hard enough that if I don't have to do it, I'd prefer not to do it. You know what I mean? Now, it's just like, can you see enough in the future to see that you could do that? Well, the good part, I don't know. But the good news is, it doesn't matter which way you do it. You can do it either way. You know what I mean?
Yeah.
And really, neither way is that bad. But you had to think to factor, or had to notice looking at it that, like, hey, I'm going to have to do some factoring. You know what I mean? And that's hard. It is. It's hard right where we're at. It is. It's okay. I tried very hard when we wrote this problem set that we include problems where, like, these different things happen, so we're kind of showing you the stuff, like the tricks that you can do, so that we build out like a really nice and even and full intuition. So like each of these problems is kind of picked for a reason, where they're not all identical, where you have to use like some different tricks as you go, and as they get deeper in, maybe the tricks get a little bit trickier or less obvious. But they're all, the idea here for all these problems is trying to teach you about like how to see the future of the problem. Like, what am I going to have to do to get this thing to work out, so that you can pick the side that's going to be the least amount of hassle. You know what I mean? Yeah. Is this helping?
Yeah.
Just kind of talking it through about like philosophically what to do, or what the point of these things is supposed to be, or what we're looking for. It's just about seeing it the right way. You know, it's like having a little bit of ESP.
I don't always see it. Like when I look at it, I see the numbers.
I know, right? And that's like, that can be the hardest thing. It's just like getting to look at it where it's just like a factoring problem.
Yeah.
Right? Like that's what it boiled down to. I'm happy to do more. I know I've been gone a couple of days, and I'm sure there's a lot of built up stuff. It's okay if there's not. Like, it's no big deal. Rita?
56, please.
Which one?
56.
56? Sure. I see. So this one looks bad because if you look at the two sides, it doesn't look like there's any obvious side to start on here, right?
I have like a feeling it's like left.
Yeah, I would want to start with the left as well. And here's what I would be looking at. So if I look at the left-hand side, I notice that these guys are like the two halves to a difference of two squares, right? So my suspicion is the trick to do this is going to either multiply the top and bottom by sine x plus cosine x and the bottom by that, or I want to multiply the top by sine x minus cosine x and the bottom by that. It's a question of like, do I want the difference of two squares on top or on bottom? So what I'm going to do to make that decision is I'm going to look at the other side. Which one of those looks the most like a difference of two squares? The top or the bottom? The top. I agree. So what I'm going to do then is I'm going to make the difference of two squares with the numerator. Is I'm going to multiply the top and bottom by sine x plus cosine x. I think that will be the best option for this. And we good with my reasoning on that?
Yeah.
Okay. That's what you tried to do. That's excellent. Okay. So there's my numerator. And my denominator then is going to be sine squared plus 2 sine x cosine x plus cosine squared. When I FOIL that out, right? And if I take a look at what I have, I'm starting to feel pretty good that I made a good choice because I see those parts matching up. Okay, well, look at what else you have in the denominator. Somehow, sine squared plus cosine squared needs to equal... Oh, and it does! That is a Pythagorean identity, isn't it? Fantastic! I feel even better now. Whoa. Okay. Now let's take a look at the numerator. So somehow this cosine squared has to go away because the only thing in there is sine squared and a 1. How can I turn cosine squared into sine squared? Yeah, just like we did in that previous problem. Cosine squared is 1 minus sine squared. And if you distribute the negative then through, you have minus 1 plus sine squared. And sine squared plus sine squared is 2 sine squared. And I still have the minus 1, and then I still got all that stuff in the denominator that was good. So I'm done. So again, it's one of those, like, notice how often I'm going back and looking at where I'm trying to get to. Almost after every decision I make, after I like do some simplifying, I'm going, okay, like, what did I get? Like, where am I close? What needs to change into what? Like, I'm always going back and looking at that other side, trying to figure out, like, what to do, what to do, what to do, what needs to change, because it really narrows down the identities that I have to work with, or the algebra that I need to do. Like, that really is enormously helpful in, like, figuring out what to do next, is I have to look at where I'm going. Like, if I'm like, go to the store and I like cover my eyes if I end up at the store, it's almost out of luck, right? I have to see where I'm at to know what to do next. You know, like, does that feels good?
Yeah, that helps a lot.
Yeah, and really, most of these problems are like, they don't get much harder than this. Like, the hardest part about this would have been this, deciding to do that as your first step. Now, you could get it to work doing it different. You know, if you start on the right-hand side, you could still get it to work. It's going to be tough, though. It's going to be much harder. Because at some point, you're probably going to have to factor, which is not going to be a lot of fun. And you're going to have to, like, use the Pythagorean to make it worse. Right, like, you're going to have to replace ones with sine squared plus cosine squared, which is not something that we naturally want to do. Like, we don't like making it bigger to shrink it back down.
Yeah.
Like, that's kind of doesn't feel very natural. Which is, I'm not sure if I could cook up a way to take the right-hand side to get the left-hand side without doing that. So wanting to start with the left-hand side is good intuition. To realize that you're going to have to make a difference of 2 squares either with the numerator or denominator is good intuition. Like, that's exactly what I'm looking at when I see this. Because this is one I couldn't just look at and go, okay, I see exactly what to do. I just had to kind of like, okay, it's probably going to have to do this. It's probably better to do it here than here. Let's see. Sophia?
Could you just show me how to, like, do regions for
25?
Yeah, like what I should look at in the circle.
Sure. So we divide both sides by 2, and then we square root both sides. right? And tangent is y over x. But the problem is that I don't have a 1 anywhere on my unit circle, right? But I do have a square root of 3 over 2, and I have a 1 over 2. So that's what I want, is where y is square root of 3 over 2, and again, plus or minus, and then x is 1/2, plus or minus. So there should be 4 answers here. And now this one, it's probably going to say plus pi over 2k, because each of those 4 answers you're going to get are going to be 90 degrees apart. So like every 90 degrees, you're going to get an answer instead of 120 or 360 degrees.
We have to write it.
No, you write them as 4 separate plus 2 pi k's are fine. It's fine. Again, on the answer key, I'm going to write it as compact as I can, because like it was less typing. But it's not wrong to write it as 4 separate things. It's just less compact. You know, if you're not into that whole brevity thing. Sure. No problem. After break sounds good. Not before. That's crazy.
Is the quiz gonna be on just on all 3 of these?
No. How about just like 5-1?
Yeah, what's it?
How about Friday?
So it's only 5?
Yeah, I think 5.1 is probably enough. I mean, it's not really 5.3 is not really any different, right?
Which ones are 5.1?
Yeah, or 14 or something, 15.
Got like word 2.
Yeah. Rita.
I'm not gonna be here Friday.
Okay.
It's like, should I take it?
Yeah, that's fine.
Okay.
If that's what you want to do.
Oh yeah, and I won't be here.
Okay.
Like, so I set a date now. Or like,
Send me an email, whatever. Come in during commute time. It's fine.
yeah. Okay, thanks.
Yeah, I'm not too worried about it. Do I look stressed?
No, I'm
Don't stress about it. 2 get dropped at the end of the semester, right? They're only 10%. It's the smallest weight for the grade.
How many get dropped in the semester?
2. Yeah, it's not even a big deal. No, but like, you know. Hey. What do we do with this? Did anybody figure out how to do this?
Probably not.
You
I didn't get Probably. Bill? Yo, Nolan's so smart.
That's not what I said to do.
So just turn into tangent, right? That's tricky, Mr. Kulik. Can't use odd even on this because cosine isn't even, so it's not equal to negative cosine or cosine negative x. Giselle?
What homework is going to be due on Sunday?
Well, here, as far as I'm concerned, why don't we have the homework set due at the end of break rather than the start?
So all Monday, not like Friday.
Well, it's not gonna be on Friday.
We're gonna have it like the day we come back.
Well, you said Monday or Friday.
What about Wednesday?
Okay, like a midpoint.
Well, I think Monday or Wednesday are reasonable days. Well,
I think,
can we?
because like after we come back from break, I won't like remember all
I'm not
that, so I
going to
need
remember
to.
anything this week.
Right, yeah.
All right, that's fine. Wednesday. We might do some new stuff on Monday then.
Or Friday we can watch like
Can
a
we do a
movie.
review day?
Well, that's what today is technically supposed to be, right?
This lesson's the hardest we've done. Like, I think, like, can I put up 2 review days?
8 review days.
Maybe it'll be a part. Maybe it'll be
I
part.
just find this really difficult. I don't really know why.
It's
Like,
yeah, I know. It's okay.
like,
Look, do you hear me listening to you? Like I am listening. I am hearing you. Did you hear what I just said?
yeah.
Said like maybe we'll do part of both. We'll do some review and we'll do some new stuff. Right? Am I doing it on Monday when you asked me not to? No. Like I'm listening. Right? Like I hear you. I understand you're working hard. I understand that's hard.
Yeah.
Like am I doing things to try to make it easier for you?
Yeah. Thank you.
Like am I just like nah, forget you, like this is what I want to do? No, I almost never do that.
Yeah.
I hear you. It's okay. You can tell, like, it's fine. I get it. Right? It's okay. I'm doing okay. You're not mad? Okay.
I'm not mad.
Okay. It's reasonable. Like I'm being reasonable.
Yeah.
Like I'm listening and like being accommodating, I think. Right? Like I'm not trying to kill you, but we got to keep we do have to keep going, you know. Rita, what's up?
Oh wait, so do we have to for the quiz know the reference sheet or the basic?
The identities,
Yeah, that is.
I project them for you to look at.
Oh, it's for the.
Yeah,
Okay,
you don't have to memorize them.
okay, thank you.
Sure.
Oh yeah. Wait, what about
Or, like, the day of- maybe it's Sunday before we come back.
I don't think I assigned it
Yeah,
yet.
yeah, I don't think.
Over at the very
Talked to me and they're like, no, I don't have this spreadsheet. So is mine messed up? Wait, yeah, this.
Well, that's worksheet 1 that we did, or worksheet 2 we did assign. I meant worksheet 1 is the one we haven't assigned
Oh, sorry,
yet.
that's what I meant. That's what I meant.
Yeah, we haven't assigned this yet.
Okay, because I thought that you signed it and I was like, I cannot do this. So
I don't think I assigned this yet.
Okay, good.
It's just solving, but it's some of them are like a little trickier algebraically.
Does that actually look better when I know it looks like
But it will be, I'm just.
Okay, so let's just kind of circle here back together. Let's discuss some dates, okay? All right, so let me look at the old calendar here. So we're off next week. So the 27th is that Sunday we get back. So 1 to 62 in worksheet 2, that's the problem set for at the end of break. The end of break, right? Instead of having it due this Sunday, we'll do it at the very end. So you do 5 problems a day and you're done, right?
Or do them on the last day.
Or you can do them all on the last day like a maniac, right? But that feels pretty doable, especially because probably a lot of that's already been done, right? Well, not for all of us, but so the test then we said was going to be on the 30th then, right? We said Friday is the quiz, and it's really just 5.1 kind of questions.
it's we're moving up. I like this. That week is gonna be worse best part.
Okay, that's definitely because it
So 12.4 is going to be the
No, I'm not taking that.
You said you would.
No, I said I didn't know. You told me that I didn't know.
What is that? Worksheet 1 review?
Yeah.
Do everything for a board.
Well, that'll be the rest of the chapter 5 stuff.
What isn't the test on the 30th?
Yeah. That happens all the time where the review ends up being due after the test.
Oh, I thought,
Right?
I thought we were going over it. After.
No. This is just due dates. Yeah, these are just due dates. I mean, I don't want to have it all due the Friday before we get back. Like, that just stinks.
Yeah.
Right? Like, I want to have some stuff that I'm going to do that week I get back. I don't need it all due. Like, come on, you maniac. Jacob's just like, can't I just do it all in one day? It's like, well, you can, Jacob. Like, that's fine. Okay. Does everybody feel okay with the due dates here that we've just kind of cleared up? Sure. If this feels unfair, if it feels not reasonable, like, talk to me. We can, like, I'm listening. Sophia.
Are we learning like what's going to be on worksheet 1 in one of those classes, or like before the test?
I mean, worksheet 1 is just solving things. Like, it's just more solving practice. It's like the same thing as the problems 15 to whatever, 46.
Okay. I won't be here on the Monday that we do that. We're going to learn it.
Nothing new.
You know what? I know it's okay. I'll just listen to the video.
Yeah. Yeah, so again, somebody said, like, what's due this Sunday? What is that? It's Sunday's the 20th, right? Okay. Nothing this Sunday. Everything is due at the end of break. Or you can think of it as due Sunday and then you do nothing over break. That's fine too. Like, whatever your preference. I don't know. Maybe you're a maniac and like, I just don't want to have to think about it for a week. That's fine. Maybe you're like, I just want to do a little bit like every day, not have to like feel like I'm blowing my brains out in one day. Like, okay, whatever you want to do, right? Is that okay?
Yeah.
We're all right?
Yes.
I mean, you can pretend it's due on the 20th. I'm not going to look at anything till the 27th. So, like, whatever day you want to get it done by is fine with me.
I have a copy of it, but I didn't do it.